This is page 5. Let's jump right in. For number 30, probably would help if you make a picture, a diagram of the triangles in question, so it's much easier to answer this one. So I'm just going to sketch a randomly shaped triangle, actually two of them because we're talking about two different ones, and put the letters on the corners, A, L, Y, and then B, E, R. Be sure they match, that's key to the whole situation. And they tell us that angle Y is congruent to angle R, and angle A is congruent to angle B. So it doesn't really matter how you draw this, the diagram should work out the same. In order to use ASA, notice we've already got the two angles, so we need to have the side between them as this answer. So I've just marked them, and now we just simply have to write what it is we need to know. And that will look like this. AY is congruent to BR. For part B, we want to use AAS, and that is the two angles and a side not between them. So for part B, I could choose either side ER at the bottom, I'll use double marks there, or I could choose the side over there on the left. So one correct answer would be segment RE must be congruent to segment YL, or you also could choose the one on the other side, AL congruent to BE. Both would actually work here. So again, in the three-letter designation, the order or the location of these things is actually very important. I'll jump down to number 30 while we're here. List three pairs of congruent sides and pairs of congruent matching angles. Usually the angles are easiest to do first. So just take a look at the first letter. That means those two corners have to match. So angle R must be congruent to angle J. Likewise, the second letter in each pair, S and K, must be equal to one another. And lastly, the third letter in each matched pair must match up with the third letter in the second triangle, so that was pretty easy. To do the sides, you can simply put a bar over the first two. Again, sides always have two letters. So that tells me RS from the first triangle is going to be congruent to JK on the second. Changing color for clarity's sake here, I can also mark the last two letters in each pair equal to each other. So we could say ST is congruent to segment KL. It also would help if you would, like in number 30 up above, draw the triangle picture, then you can sort of mark them off as you go. For the last correspondence, it always works out that it's the first and third letters in each pair. So RT is congruent to JL. And as I'm doing this, I'm always looking back at the triangle congruence statement to figure out what matches with what. Three sides, three angles. So let's go over and get these other parts here. Again, it might help to draw the triangle picture for each of these. So let's start here. We have triangle Dan and triangle KUT. That's a K up there. UT. And they tell us angle A. Again, let's make our marks on our figure. That's key to working with these guys. And side DA is congruent to side KU. And if we want to use SAS, again, we need parts in that order. So as I look at my first triangle, triangle Dan, I see the side marker, I see the angle marker, and the other S has to be right next to the angle. It's got to go in order from side angle to side right there. Same thing must happen over here. So this is the side correspondence we need as the answer for letter A. Let me come just above here where I have a little room I can write that answer. So AN segment is congruent to segment. You go look at my letters, UT. And I can even tell that if I look back at the congruence statement, there they are. That is a correct matchup. I just needed the picture to help me see where it was. For question B, I'll change my pen to black. Here we need two angles and a side not between them is what that says as far as the order goes. So the blue markers are my originals. So if I would use the top angle up here at K and D, I would actually have the side sandwich between the two angles. I don't want that to happen. I want my two angles to show up, and it's the side not between them. So as I walk around my triangle in this direction now, I come across an angle, the other angle which was marked earlier, and the side here. That is the correct order. So I need to write angle N is congruent to angle T for this one. For number 31, second number 31 here, they've given us three statements about two different triangles, and we're supposed to write a triangle congruency statement. I'll write this down below. That would look something like this. Triangle, name it by 3 letters, equals another triangle named by 3 letters. We just got to figure out what they are. So doing a sketch for this will be a big help. So I'm going to draw, again, two triangles, just kind of randomly shaped. Doesn't really matter for now. And it says angle Y, I'm just going to pick one corner to start at, equals angle E. At least I know the Y and the E match up. So I've used this statement. Find your second one. It looks like on your triangle there is another point called point J. I'll just put it right here, somewhat randomly, and that's supposed to be equal to the other side, which is called EW, so the W must be there. And then I check out my third congruency statement. It says there's a side YN somewhere. I haven't used the N yet. That must be over on this side. And that one is supposed to be congruent to EI. So now it looks like my triangles are all set to go. It looks like, by the way, that the reason I could say these are equal would be side, angle, side. But the answer they asked us for is to write the names of the triangles. So now I'm just going to randomly start over here at point J and call this one J. I'm going to go up to Y and come back to N. If I start there, I must start here. JW matches. Y matches with E, and I matches with N. There we have our triangle statement. Next portion here, decide if the triangles are congruent to one another or not. So we're going to check out if we have matching parts here. Notice here I have an angle pictured, a side and an angle, and this side is between them. If I look at the other triangles, starting at the double marked corner like I did in the first one, I have angle, side, angle in this one. So it says name the theorem that justifies my answer. All they want you to write is ASA. If we jump down below this one, pretty obvious here, we've seen this many, many times. This is a classic sketch of side, side, side. I'm going to jump back up now to number 33. Notice I don't have enough marked as it stands, but I can add in some information because we've seen this reflexive property shared side business before. So now I can see I have side, angle, and a side, and notice that the angle marked, and if I start on the other side of things, side, angle, side in this triangle, I have that same thing in both triangles. So the answer here is side, angle, side. So for 33 we had to add a piece of information on our own. It looks like for number 34, I can see we have matching sides, and we have a second set of matching sides. So I'm either going to need to find another side or another angle to add in. So if I add in these two angles here in the middle, and I think you know the reason, we have side, angle, side for this sketch. So it helps if you sometimes add pieces of information. Jumping down now to 36, I have a side match up here as I'm going around this direction to the nearest matched corner. I have a couple of angles attached, and as I go this direction I have the same thing happening. So the answer for 36 is side, angle, angle. For 37, I have two sets of angles marked, so I need some other information. And it looks like the shared side between the triangles will provide that matching piece for us. So here I have AAS. Again, you can write that backwards too, if you'd like. SAA. And our last couple samples are answered in a similar fashion. Third piece of information, the shared side. Third piece of information, the vertical angles. And it looks like we have another shared side situation going on in our last one. So that one's pretty easy to recognize. This one here for 39 we've seen before a few times. That's a classic angle, side, angle order. And we have angle, side, angle here. And our last one, side, angle, side, angle, side for our third.